Okay, so let's try to make a make an isomorphic between G1 and G2. So we see that um, what's the strategy of solving this one? Uh, so it's not easy question, but it depends on complications of the graphs. So we really will eye on the degrees of the two graphs. So we see that A 1, and what we have is so F D degree 2 and B E C degree 3. And here 4 is degree 1, 5 degree 1, 2, yes, excellent. 1, 2 are degree 3. All right. Now we see here the only degree 1 should really it is this one. So A F A F of let's write in this way. A will go to 1. That A here, A is degree 1. This is degree 1. So they must be isomorphic. So the function they should map A to 4. A goes to D. So in the same to construct the isomorphic, so we need the second map is like the way of the edges. The map of the edges also should work. So A goes to D, so 4 goes to 6. This means D, B, which number? 6. And this number should be 4. Okay. So A was 4, D is 6. Now, from 6, it goes to 1. And from D here, it goes to C. So this must be, it must, C goes to 1. Now, here is the important part. 1 goes to 3 and degree 3, and 1 goes to 2. Degree 3 as well. 1, 2, 3. C also, so let's highlight this one. Now, now we have two options here and two options here. And D, C goes to E, B. Both of them are degree 3. So how to choose them? Well, uh, we can just pause or choose one of them. Proceed. If you make a mistake, if you get a contradiction, then go back and choose the other choices. That's the best way that I can tell you. All right. There is nothing that we can do more than this. However, we see that only some strategy can ease the job for us. So we used A, D, C. So F, C, 1. So therefore, this guy should go to 5. So I will write F goes to 5. All right. So now BE. So how let's look at this scenario here. F connected to B and E, both of them unfortunately. So if 5 is also connected to both of them, unfortunately, 1 is also connected to both. 1 here connected to 2 and 3. The corresponding of 1 is just this C. All right. So maybe during the exam, if you have colorful pens, it will be helpful. So this mean what's the meaning of this one? This means you can relate to sorry, B to 2 and E to 3. But if you choose B goes to 3 and 2 E goes to 2, that will be also okay. If you write this one, I will give your mark, but some other, because I know that how you chose this one, but it's very safe if you can write the map of the edges as well. This means F, you need to write this map as well. Like A from D, 4 to 6, then D to C, 6 to 1, and from C to E, and there is 1 to 3 as well. Uh, and there is 3 to 1 as well, and B to E as well, B to E. And what else? C has got to, C goes to B. Definitely 1 goes to 2 as well. And what else? F goes to B. 5 goes to 2 as well. 5 goes to 3 as well. F goes to E as well. I can see it. F goes to E as well. So, or you can add this one. The map of A, B, or 6, D, C goes to 6, 1. C, B, C, F, B, F, E, can complete these things. It's easy. You can complete. Just look at here. The way that I wrote here, you can complete here. All right. All right. To optimize, I will pause the recording. All right. So we try now the question 4 of the second test mid-semester of the Thursday version. Uh, so is that the sign of number is P if it is positive. N is for the negative, or Z is the number of the zero. All right. X is -2 minus 1, 0, 2, 3, 4, and define the relation on this set on X or X times X. By this one, AB and AB has relation with CD. If how does it define? It's like this. A and C, they have got the same sign. B minus D has to be divisible by 3. Show that R is equivalence. So let's see this one. To show that R is equivalence, we prove that R is what? Reflexive. Formal exam? Maybe, yeah. Transitive. Yeah, I know that you don't like, but I'm not. Maybe. So R, X, all possible. So what's X times X is X times these, like any pairs of coming from this set. -2, -2, -2, -1, -2, 4. Then -1, -2, -2, -1, -1, 4. -1, no, 4, -2, 4, 4. These are the all possible X, but R is just some of them. In fact, R is subset of X times X, and it has got the feature of reflexive, symmetric, and transitive. Let's prove the reflexive. We want to prove A, B has relation, any arbitrary member of X times X from here has relation with itself with this relation, A, B. We see that A, so it says, what's the definition? A and C has same positive. A and A, they are same number, so they have same sign. We also see that minus B, so second minus second, B minus D. So here minus B is by what? 3. All right. Two. Uh, we want to prove that we want to prove for symmetry if A, B, then A, B. All right. So from here, we see that A has the same sign since A, B relation with C, then A and C ha- or C and A have same sign. Also, minus D, yeah? So it says that B minus D. B minus D is divisible uh, by 3. So D minus B also divisible by 3. Therefore, CD relation with A has relation with B. You know, C and A have same sign and D minus B has the same sign. All right. No, actually, D minus B is divisible by 3. You know, if 9 is divisible by 3, so as -9 as well. All right. B minus D is divisible by 3 is 3. Okay. So D minus B is just -3K. Now, we wanna prove if AB has relation with CD and CD has relation with EF, then AB has relation with EF. This is the meaning of transitivity. All right. So to prove this one, we see AB relation with CD. So let's write A have same sign E minus D is divisible by 3. Or B minus D is equal to 3K. C, the relation with EF means C, E have same sign. D minus F is divisible by 3, or D minus F is equal to 3K prime. So from AC have same sign, we conclude A and E have same sign, and not also we see what do we want to prove? To prove that AB has relation with F, A and E must have same sign, which we did, and we need to prove that B minus F is also divisible by 3. B minus F is equal to B minus D plus D minus F is equal to, the first one is from here, plus one is 3K prime. From here, 3 factorize, we factorize 3, so it will be K plus K prime. So B minus F is divisible by 3. Therefore, A, B has really a relation with E, F. This proves the I3 transitivity. Now, part B of the question, it says that find the equivalence class of -2, 3. Well, -2, yes. All right. So what are the possible of -2 and 3? Well, the possibility is, let's go to see. Are you okay? All right. So let's see this part, x by x. From here, -2 and 3. So I will focus only those ones that -2 and -1, because the first, to prove this one, -2, 3, find equivalence class. So this has to be A. So let's write C, D. This guy should have same sign, means This can be which numbers, like -2 itself and -1. So I will choose all the -1, -1, -2, and until -1, 4, -2, -2, until -2, 4. So see, okay, so in first thing is we were able to diminish a lot. So actually we ourselves to these two rows. Okay, so we won't look at to these lines because -2 and -1, it should be like same sign. Now we are going to see for the second element 3. This should be 3 minus d has to be 3 minus d has to be divisible by 3. All right. Now, which numbers? Well, what are those numbers? 3 minus d. D can be any of these. From -2 until 4. So the best way of to see this one. So first of all, we write everything. -1, -2. So -1, -2, -2, 0, -2, 1, 3, 4. So 3, now look, let's look at here. 3, the second element, minus any of these second elements should be divisible by 3. 3 minus -2, it will be +5. So not this one. 3 minus -1 with this one will be +4. So not this one. 3 minus 0 is okay. We can choose it. So also before we have the second rows as well. I will just write quickly so to be visible for everyone and people at home as well. Wait, this should be -2. These should be -1. One. Okay, so 1, 4. So if this is not correct here, so this should be not correct here. This one. What did you say? Sorry. 3 minus 1. This cannot be correct. This cannot be correct because 3 minus d should be divisible by 3. 3 minus 1 is 2. 2 is not divisible. So as here, 3 minus 2, 1, not Not. What about this one? 3 minus 3 is 0. 0 is divisible by 3, yes. So we will consider this one, this one. 3 minus 4, no. So this one as well. So the answer will be this one. Minus 2, 3 is written. This guy, this guy. Minus 2, 0. Minus 1, 0. Minus 1, 3. Okay. Okay, so it's until here. Okay, we are trying to do question 6 of Thursday version. So we see that induction is the method that it's been advised. So base step n equals 0. So 9 power n minus 1, 9 power 0 minus 1 equal 1 minus 1 equals 0. So 0 is divisible by 8. Therefore, base step is true. Now, assume that inductive step true I dot e comma n equal k is we prove the statement Pn. This is Pn is true for n equal k plus 1. All right, inductive. So it's better write neatly. So I write inductive step since pk is true, so 9 power 9 power k minus 1 is divisible by i.e. 9 power k minus 1 is equal to 8 times s. Now, for proof of p of k plus 1, we have that 9 power k plus 1 minus 1 is equal to 9 times 9 power k minus 9 plus 8 equals to, we factorize 9 times minus 1 plus 8 equals to 9 times, I will write this part from here, 8s plus 8. From here, I will factorize 8. It will be 8 times 9s plus 1. This means 9 power k plus 1 minus 1 is divisible by 8. I dot e p k plus 1 is true. Therefore, it being true for base step and inductive step, the statement Pn is also true. Okay, like this. So of course I did a little bit, I wrote a little bit more than enough, but it is the way that I'm teaching. So every tiny single word can help you to understand deeply. Okay. Okay, now we are trying to do this question. Cross call. So at first we will list the edges. So we see that maybe A, B once. So I focus on the low-costed edges. F, 1, 1. I also, now I go to focus on 2, C. Now I have to focus on the 3. So I cannot use this one because so yeah, so this I cannot focus on this one here. So you see, because if I draw this one, it will be a cycle. What do I need is just I have covered all the vertices, but actually uh, I need to connect this. It has to be three. Three means connected graph. So I either four or this three or this guy. So we can use either this one or this guy here. So we can use maybe as well as three. But actually you can get, of course, you can get this one as well. And draw this one as well. All right. Yeah, but we don't choose both of them. We will choose one of them. Uh, well, actually, you did the cost is okay, but the you made it like you want to do a DFS. Yeah, it should look like as the same. You should not change the. It will be easier for the marker as well, but definitely when you draw it, they are small graphs, so they will be isomorphic. We can't really diminish marks from you, but it should look as the same subgraph of that. And actually, minimal spanning tree is a subgraph of the original graph such that it is a tree and it is the cost has been minimized. So so it can be correct, but it should be so you should really make the you origin it should look like a original one. So let's do uh this question as like with the using prime algorithm. Okay, so just a minute. So for the prime algorithm, so we choose just one vertex. I will start with A, uh, adjacent. Then I will go to F, adjacent. Among these things, B is the smallest two. Now, among these things, I will get which one? This three, or I could choose this one as well. I could choose this one as well. So three, then from here D, so I have E, and I covered all the vertices and it's connected tree. So in the both cases, it's the total cost is 8.